Some languages implement data hiding in a class by declaring the data and methods as private or public. Private data and methods can be used only by the methods inside the class, while public data and methods can be accessed from outside the class as well. So this part of the class can be used inside this class only. In Python, there is no such concept of private or public. First, let us see why there is a need of this distinction between private and public when working with a class. The users of a class are generally called clients, and the client code uses the class by instantiating it, that is, by creating its objects. So suppose we have these three clients that use this class named product in their applications. These clients can access this variable data3 and can call these two methods, method x and method y, through the instances of the class. But they have no access to these variables and these methods. The creator of the class has chosen to hide them from the user because these things are used in internal working of the class. They are not required by the user. For example, in a car, you have access to steering and brakes. You don't need access to all the internal parts of the car that make your car move or stop. Those internal details are best left to the creator of the car. If you get access, you might inadvertently damage something and the car will stop working. Similarly, in a class, only those parts are exposed to the user which are required. Other internal details are hidden in the form of private variables and private methods. This part that is visible to the user is the interface of the class, and this part is the implementation. The interface of the class generally comes with a guarantee that it will not change with time, but implementation may be changed without any warning. So a private method or a variable may be deleted or its behavior can be changed without any notice. These changes may be done to fix some bugs, to change some functionality, or maybe to improve efficiency. Any change in implementation does not affect the client code because client is not using the implementation part. It is not concerned about how the class is doing its work. It just gets its work done by calling these public methods. If we again take the car analogy, the internal parts of the car may be changed or can be made to work in some other way, but your steering and brakes will work in the same way. So the interface is generally not changed. Now let's come to Python. In Python, everything inside the class is public. Clients can access any data or any method. So if these clients use this Python class, they are free to call any of these four methods and they can access any of these data variables. Python does not enforce any access restrictions on data and methods like Java and C++ do. However, there is a naming convention that is used to indicate that a certain attribute is meant to be used inside the class only. You can use a leading underscore on an instance variable or a method to suggest that it is private and should not be used outside the class. These variables and methods are technically just like any other variables or methods. They can be accessed outside the class also, but the leading underscore indicates privacy. This way you can discourage clients from using the private things of a class. However, you cannot stop them from doing so. So Python works on the policy that we are all consenting and responsible adults and know how to use the code. Its philosophy is based on the trust that users of the class will respect the convention and documentation and use the methods and variables appropriately. One of the reasons for making everything accessible outside the class is debugging. When you need to fix a bug, you have to sometimes access the private attributes of the class. So if you prefix a variable or a method with a single underscore, then it indicates that this name is non-public. It is only for the internal use of the class and should not be accessed outside it. If you prefix a name with double underscores, Python will do some name mangling and that attribute will not be directly visible from outside the class. For example, this is internally replaced with this name, where my class is the name of the class in which this attribute is defined. These names are mangled by prefixing with a single underscore and the class name. So these names are not directly accessible from outside the class, but they can be indirectly accessed. So if you use a name that starts with at least two leading underscores and has at most one trailing underscore, that name is mangled by Python and it cannot be directly used by the user. This naming can be used for your non-public members of the class to make it difficult for the user to access those members. But this name mangling mechanism is not there in the language for this purpose. Its purpose is to make the name specific to the class so that there is no name clash with subclasses. To indicate privacy, you should use a single leading underscore. Then there are names that start and end with two underscores. We have seen one such name, dunder init, and we'll see many more. These types of names are used by Python for its internal use, and we should not write our own names that have double leading and trailing underscores. A single trailing underscore is used to avoid name clashes with Python built-in names. For example, if you want to use the name class or range in your program, you can use it as class underscore or range underscore. It is best not to use these built-in names in your programs, but if you ever need to do so, the convention is to use a trailing underscore. Now let's go to idle. We have this class name product in which we have these two variables and these two methods. This variable and this method are prefixed with an underscore, which indicates that they are not supposed to be used outside the class. Let's run this now. We can access data 1. We can call method A. This underscore data 2 also can be accessed outside the class. And this underscore method B can also be called. Although these attributes are prefixed with an underscore, it is possible to access them outside the class. For Python, this underscore does not make any difference. It is just a convention, and programmers should respect this convention and not access these attributes like this outside the class, unless there is some need for debugging or something like that. Now let's change these single underscores to double underscores. Let's run this now. Now this attribute cannot be accessed, and this method cannot be called. Let's call the dir function on this instance object P. We can see that the names of these two attributes have been mangled. They have been prefixed with the class name and an underscore. So we can access these attributes with these names. So we cannot directly access these attributes from outside the class, but we can access them indirectly. Inside the class methods, these variables can be accessed directly.